Hey everyone, Professor Z. I'm going to talk a little bit about inferences, which is a particular thinking skill that is, it's really used across the disciplines. It's used a great deal in science to come up with explanations for why things are happening. So, an inference is to, the verb form is to infer, to kind of have an educated guess, right? So you take the information that's available and you try to, you take the facts that are at hand and you try to come up with an explanation for why things are how they are, right? So you're making an assumption based on something you see, something you read, or something you experience. You're trying to explain that phenomenon. Here's some like just pretty straightforward examples, right? If we, the scientific method is really about, observation and observing things, observing the physical world, and trying to use those observations to come up with hypotheses about why things are how they are. So if I see an apple is missing a chunk, I might infer that somebody took a bite out of the apple, right? I haven't seen somebody take a bite out of the apple, but a chunk is missing. There may be some other explanations. It could have fallen on a rock and taken out part of the apple, but I might infer if I look at it and it looks like there's some teeth marks, I do a little further observation, I might infer that somebody took a bite of the apple. If I see a girl dressed in shorts and a jersey and she's holding a basketball, well, I might infer, hey, I bet she's on a basketball team. Well, why? Because I don't see a lot of people who aren't wearing, I might see people with a basketball who are not on a team, but if they're also wearing a jersey that appears to be a team's jersey, then I might start to infer that she's on a basketball team. If I see shoe-shaped footprints in the mud, I'm going to infer that a person has been there. If I'm out walking in the woods and I see hoof prints, I'm going to infer that it's probably a deer, even if, if I don't know my footprints that well. If I see pieces of eggshell in a nest, I may infer that a bird hatched from an egg. It's also possible that another bird came along and ate the egg, but my inclination might be to say that a bird hatched, right? I might infer either of those things based on other things that I observe. So I'm trying to draw conclusions, right? I'm trying to explain why something has happened. And you'll remember in the video you watched about reading in the sciences, he had a kind of chart up at one point where he kind of talked about this, right? He was saying, science is based on collecting facts, right? And that's the what, right? And then you come to the question of why. Like, why are these facts facts, right? And that's where you get to hypothesis, right? And that has to do with like a single event, right? And then from there, you might want to extrapolate or extend. Remember, we talked about that when we were talking about definite context clues, right? You might want to extrapolate from that single event to all events, right? And at that point, if you're able to, right, if a bunch of people, you remember Neil deGrasse Tyson, the video you watched of him, he was talking about scientific consensus, right? Well, then you start to get to laws and to laws and to theories, right? Where, hey, a bunch of scientists have tested this. They've all come to the same conclusion. So I think we've got a law of gravity now, right? I think we have a theory that explains, the theory of evolution, right? Which takes, starts with perhaps a simple fact. From there, we come to a hypothesis, we test it, we get a law that leads to a theory, okay? So this is, just how knowledge gets created in scientific disciplines, okay? What we're going to try and do is we're going to try and be scientists, okay? We are going to we're going to look at the COVID data for Philadelphia, and that'll be the factual data, right? We're going to digest the facts, and then I'm going to ask you to try to develop a hypothesis about the facts as you see them, okay? So, and we're going to kind of share our insights with one another, and let me just show you that here, okay? So in our module this week, you're going to see a link to this page. It's the Philadelphia Inquirer, and they are giving people free access to their COVID data. So on this page, you're going to see data for Pennsylvania, for Philadelphia County, Delaware County, New Jersey, right? And this is all data. It's all factual data, right? And as you scroll down, you're going to see a lot of different numbers, right? Number about the total number of tests, the total number of cases, total number of deaths. Over here, you're going to see it by county. There's regional trends. And if you keep scrolling down, you could also see since March, you can see in the past 14 days, and you can see all the counties here in Pennsylvania. If I click show all, I would see all of them. Here's cases and deaths. So there's a lot of information. What I'd like you to do is just spend some time, spend, I don't know, 20 minutes kind of looking at all of this information and just see what it is that you notice and see if you can start to ask yourself questions about why the data is how it is, okay? And I'll give you some examples, right? So if I look here, right, I see first off, I have to make sure that I understand how to read this, right? So I have to look at the legend. Total reported cases per 100,000 people over the last 14 days. A lot of times you're going to see data, especially about COVID, reported as cases per 100,000 people. That way, you can kind of compare areas that are less dense with areas that are more dense. Philadelphia, in theory, is probably just going to have more raw cases because there's more people here. But if you compare it for every 100,000 people, how many cases you have, you can more readily compare areas with different types of populations. One thing I notice here is it looks like in the middle of the state, they're experiencing more cases per 100,000 people. So my question might be, why is that? And then if I can come up with an educated guess, an inference, right, that could be my working hypothesis. So that's what I want you to try and do. I want you to find something on this page that you're curious about and ask yourself why that is the way it is, and then try and come up with your own hypothesis. I think it's like this because, right? So I'm going to give you my example. I see that in Pennsylvania, in Center County, they have what looks to be the highest number of cases per 100,000 people. I'm going to guess that this is happening. My guess would be that the reason that right now they have the highest number of cases is because State College is there, okay? Penn State is back in session. So I'm betting that college reopening might be driving, right, those numbers. Now, I don't know if my hypothesis is true or not. I don't know if it's correct, right? But from there, I could go and test it, right? I could do the sort of scientific stuff that scientists do, right? I can go look at the data. Well, how old are the people who are getting tested? Are they connected to Penn State University? I may find out that my hypothesis is wrong, right? Or I might find out that it's right. Say I find out it's right, it would actually be interesting to then look at other places where there are large colleges that are having reopenings, right? What's happening in North Philadelphia? Is that, it was Temple's reopening. Did that drive COVID cases up there, for example? And from there I can start to look at not a single event, but at, more events. And then I can start to have, I may get to the point where there's becomes a law about COVID opening, COVID and college openings like that. You can guarantee you're going to see a certain amount of COVID cases if you don't do A, B, and C or something like that. Maybe not. Maybe what happens is I find out, it had nothing to do with State College. Something else is driving the increase, right? Because there are some other counties here around there that are also seeing an increase. Maybe it's just slowly spreading across the state. Not sure, right? But the thing is, I want to look at the factual data and come up with my own hypothesis. So that's what I'm asking you guys to try and do this week. I'm not asking you to test your hypothesis, just to look at the data, notice some factual information that you find peculiar or interesting, and then try and come up with your own explanation, your own hypothesis, your own inference for why that may be the way it is. Good luck.